When we talk about network layer packets, we're talking about IP or Internet Protocol, and we have to be more specific and tell you which version we're looking at. So IPv4 is mostly what we've been assuming so far, and packets in IPv4 naturally start with 4 in the version field at the start of the packet. So that's the first 4 bits there. Next is a header length. This tells us how big the IP header is because we have some number of options. It's not a fixed size. And so 4 bits are used for the length expressed in 32-bit words. So a typical number here is 5, meaning 1, 2, 3, 4, 5, 32-bit words and no options. Type of service is something that's not pinned down precisely in the IP spec, but is meant for local network use or network use at some level to categorize different packets and determine how to prioritize them. The datagram length field tells us the size not just of the header, but of the whole packet. So you may recall that a TCP segment does not have the total size in it, but it doesn't need to because another layer, the IP header, does have that total size on it. IPv4 has an identifier in each packet. This is normally not used, but the intent was that packets might get too big for some parts of the network, in which case they would have to break up a larger packet into some smaller packet representations, and then you would need identifier to say which original packet the smaller packets go with. And flags and fragmentation offset are part of that. This was important in the early days. It turns out not to be so useful now, and it would be nice to get rid of it if, say, we make a new version of IP. The time to live flag we've looked at before. That's how many hops this packet can still take before it is discarded. Most of the fields in an IP header are going to be preserved as is by a router as it receives it from one interface and sends it out another, but the time to live part of the header will be decremented as it's sent back out. These 8 bits here for upper level protocol specify the transport layer, so it's upper as in the same sense of our pictures. So there are constant numbers here that can mean TCP, UDP, ICMP, and so on. The header checksum is just like the checksum field in TCP, but since the transport layer checksum can take care of its own header and data, the checksum here just covers the IP header. Then we have a source address, which is of course 32 bits, and a destination address, also 32 bits. Note that there are no port numbers in an IP header because port is a transport layer concept, UDP ports, TCP ports, and so on. Finally, we have some options that might be in an IPv4 packet. These were intended to make the protocol flexible and adaptable, but they also complicate things. Even if you're just looking at IPv4 packets, you might have some extra options to deal with if you're a router. And it would be nice if we could get rid of them to make the life of routers easier, but in IPv4 those options are there.